All right. I'm just curious, have y'all graphed this before? No. All right. Well, you know what you do when you want to know a picture of a new graph? What's the first thing you do? XY chart. Right? That's what you're going to do every time, right? It's not just this course, it's next course, everything else. Anytime you got a new graph and you want to know what it looks like, you're going to make an XY chart. So I'm going to make an XY chart. And on my XY chart, I get to pick any values I want to for X. That's the beauty of an XY chart, right? So the problem is a lot of times when people pick an XY chart, they pick the same values. They always pick like -2, -1, 0, 1, 2, right? Well, I'm going to have some issues with that, right? See, my issues with that are, one issue is, can I take the square root of a -2? No, so this one doesn't work, right? You really can't take the square root of -1 either, can I? Like, you can't take the square root of we're not using imaginary. Okay, what's the square root of 0? 0. You can take the square root of 0. It's just 0, all right? What's the square root of 1? 1. What's the square root of 2 without a calculator? Good luck, all right? It's 1.4142 and some decimals, all right? But, you know, if you could pick anything you want to, why would you pick 2, right? Right? You don't know that off the top of your head. If you could pick any x value you want, what x value would you pick to make your life easy? 4, right? And then what's the next one I'd pick? 9, right? See, if I plug 4 in, then I get a 2. If I plug a 9 in, that's going to give me a 3. All right, now I have some points I can plot. Oh, fortunately I have graph paper. Okay? So at 0 I get a 0, at 1 I get a 1, at 4 I get a 2, at 9 I get a 3. I mean, I guess technically I get 16, I can get a 4. And when I graph this, what it ends up looking like is this little curve thing. And how you draw it, and later I'm going to explain why we draw it this way, this is actually a parabola, half of a parabola on its side. So when you draw it, I want you to think you're drawing half of a parabola on its side. Can everybody kind of see it's like half your parabola, but it's turned on its side? Is everybody with me so far? All right, well, you know, when we graph something, anytime you graph something, we need to talk about domain and we need to talk about range. Space. Right? And domain is how far left and right the thing goes. Range is how far up and down it goes. All right, so how far left does it go? 0. How far right does it go? All the way, and so this gives me from 0 to infinity. Does it include 0? Yeah, we got that dot, right? We plotted the point 0, 0. It includes that, so it includes 0. So far, so good, right? Now, Alex doesn't really get its act together, because sometimes in Alex they want your answer as an interval notation, right? But in the questions I'm going to ask in Alex this time, they're going to want their answers with inequalities, right? So I want to make sure we can handle the inequality, right? And so how we handle the inequality is, right, we're going to have to, you know, 0 to infinity kind of represents this line, like it's 0 to infinity, right? Does everybody see that this interval notation represents that? And the way we're going to represent that with an inequality is we're going to say x is greater than or equal to 0. Right? Another way of thinking of domain in this case is, imagine you have a giant flashlight right above the graph. Wherever the shadow is your domain. You see that we have our shadow right here? Right? If I put the flashlight here, we get the shadow here. All right? And that goes from 0 to infinity, so our x is greater than or equal to 0. Right? All right, now let's talk about range. How low does it go? 0, right? How high does it go? To infinity. So if I were writing this in interval notation, I would say that, you know, this is 0 to infinity this way, but Alex is not going to want interval notation. They want inequalities. And so the way we're going to have to write this, as far as range goes, is going to be y is greater than or equal to 0. I want to make a big deal about why we call it x and why we call it y, right? Domain is how much of the x-axis you use, right? You put the flashlight, it's what shadow hits here. Range is how much of the y-axis you use, meaning if you put a flashlight here, do you see if I put a flashlight here, the shadow is going to be here? It's going to be the top half of the y-axis, right? So in ALEKS, when they say write the domain, and you write, you have to say for your domain it's x greater than 0, and you have to say y greater than 0 for the range. Do you see why we have to use x's for domain and y's for range? That's a big deal, right? So are we okay with this? Right? So there's our graph. All right, well, now that we talked about the graph, we do stuff with the graph. We move it around, right? Do you remember when we moved the parabola around? We had a little parabola and we moved it left, right, up, and down last semester, right? And flipped it, stretched it, and all that stuff. Well, the good news is, whatever the rules we use for parabolas are the same for this little square root function. For example, if I have y is equal to the square root of, I'll do the same thing I did the second period, the first period. Let's say I give you y is equal to the square root of x plus 2. What does that plus 2 do? Moves it up 2. Is the 2 inside or outside? It's outside. Actually, stop taking notes. Let's review what we remembered about parabolas, right? I just talked about the parabolas, but I didn't actually review it. So let's review what we know about parabolas. So don't write any of this down, right? We'll come back to that problem. What we know from parabolas. If I give you y is equal to x minus 2 squared plus 3. What did that plus 3 do to my parabola? Moved it up. What did the minus 2 do to the parabola? Goes backwards, goes right. So I'm going to say something, and I hope it kind of remember it kind of rings a bell. Anything outside the parentheses has to do with the y, so it's going to impact up and down. Anything inside the parentheses impacts the x's, it's going to move left and right. Right? And everything inside the parentheses is always backwards in what you think. And kind of my loose explanation why was, you're going to set this equal to 0. Right? Does that sound familiar? So this says, take my parabola, go right 2, up 3. Right? Okay. So now, let's go back to this. This y is equal to the square root of x plus 2. What is that plus 2 going to do? Move it up 2, right? Well, you don't have to believe it, right? At this point, I'm gonna do the xy chart. So I'm going to do the xy chart. Now let's talk about what values of x I'm going to pick. What do you think my first value of x is going to be? 0, right? Remember, xy charts, you pick something that makes your life easy. So 0, 1, 4, and 9, right? If I plug a 0 in, well, 0 plus 2 is 2. Plug a 1 in, 1 plus 2 is 3. Plug a 4 in, 2 plus 2 is 4. Plug the 9 in, 3 plus 2 is. Are we okay with that? And when I graph this, so at 0 I'm at 2. At 1 I'm at 3. At 4 I'm here. And at 9 I'm here, right? Just plotted those points, okay? Now when I connect the dots, I try to draw my half parabola. Does it look like it shifted up 2? Well, of course it did. You know what that plus 2 did? It says take this point, move it up 2. Take this point, move it up 2. Take this point, move it up 2. Take this point, move it up. Do you see how it just took all the points and shifted them up 2? And that's what the plus 2 does, right? All right? Oh, I guess I should talk about domain, and let's talk about range. Okay, what's my domain?
2.
X's.
2.
Flashlight. Which light? Where's the shadow? You see, we're going. Remember, domain is how much of the x-axis we use, right? Okay? So how much of the x-axis we use? All right. So here our domain is 0 to infinity. All right? But Alex is going to make me do this. Okay. What's my range?
2.
And now we get the 2. Does that make sense? So our range is going to be, 2 to infinity, but Alex is going to want me to write y greater than or equal to 2. Okay? Does it make sense? All right. Okay. Oh, shoot. I need a bigger board. I hate that I kind of like to keep this work up here, but I need the space, so sorry I'm going to have to erase this. The most expensive version of erasers you could possibly get. Okay, well, we have different colors, I should use them. So, what if I ask you to graph y equals the square root of x yeah, we'll do that. So let's say I want this. Before we start the problem, what should happen? What does this plus 3 tell me to do? Move it left 3. What's the plus 1 tell me to do? So this basically says take this little half parabola, this curve thing, and go back 3, 1, 2, 3, and up 1. Yes?
I know you've already said, but so if it's plus 3, then you go left, and if it's minus, you go right.
Yeah, I'm about to come up. Give me a moment.
Okay.
That's the rule, right? Right? And it has to do with what makes this 0, but we're going to see something. Let me finish. Okay? Are we okay with this? All right. So we go back 3, up 1, and so our picture should be this little red line that goes around here, right? Well, how do we? Does that make sense? All right. So I want to plot some points. So I'm going to do my little XY chart. And now let's talk about what we pick. What could I pick that makes my life easier? Remember, you have to pick x values, right?
1.
A 1 works because I plug 1 in, and that gives me square root of 4, right? Square root of 4 is 2 plus 1, which gives me 3. Is there anything else I could pick? Y'all are really not liking negative numbers much, are you? What would be an easy negative number to plug in that would give you a nice answer?
-3.
-3, right? Is that okay with -3? Because if you plug -3 in, that makes that a 0, right? That makes that a 0 plus 1, which gives you 1. Is there another negative number? -2, right? Because that gives me a 1 plus. See, I mean, what you're doing is you're saying, wait, I like square root of 0, square root of 1, square root of 4, and square root of 9, right?
-3 be 0. Oh wait, no, plus 1. Yeah, wouldn't it?
Oh, that would be a 2, yes. Yeah, sorry. For those of you that not, you're interested, like, remember, square root of 0, square root of 1, square root of 4, and square root of 9, right? And so what you ask yourself is, what can I put here to give me a 0, right? Well, -3. What can I put here to get a 1? Oh, -2. What can I put here to get a 4? Oh, a 1. I mean, I guess to figure this out, what can I get to get a 9? What's that, a 6? And so we end up with a 4. And so now when I plot all this at -3, I'm at 1. -2, I'm at 2. At 1, I'm at 3. And at 6, I'm at 4. And is that what happened? I mean, did this go back 3 and up 1? And just for fun, let's talk about the domain and range. So if I look at my domain, what's my domain? -3 to infinity, right? Can you see if I put the flashlight here, that's going to light up from here over? Yeah. So that's from -3 to infinity, all right? But Alex doesn't want this. They want the inequality. So we're going to have to say x is greater than or equal to -3. What about our range? To where? Up, right? Does everybody see our range is 1 to infinity? So our range is going to be 1 to infinity. But Alex is going to want us to say y is greater than or equal to 1. Does that part make sense? All right. Now, yeah, so we're okay with this whole shifting thing. Is this the same thing we did with parabolas for the most part? I mean, it's the exact same thing. I mean, our picture is a little different, but what we're doing with it is exactly the same thing. So, I do have an issue, though. Well, not an issue, but like you're going to have questions where I'm going to ask, what's the domain and range? And I would really like to not graph things, right? Like if my goal is to find the domain and range, I don't want, I don't want to have to graph it every time, all right? So I guess the question is, can we do this without graphing? Like if I wanted to, if this was my function, could I figure out what the domain is without actually graphing it?
Yes.
Okay? Okay. And you can almost visualize it, but so how would you do it?
So for the x, the 3, just make that a negative. And you know that's where you start.
Yes, when it's real simple.
Whenever it's inside the parentheses.
Again, yes, when it's real simple, all right? This is an example of real simple, all right? Here, domain are like legal values. So here's how I want you to think about it. If I give you the square root of something, can I take the square root of a negative? Am I allowed to take the square root of a negative? All right, is everybody okay with that statement? So you can't take the square root of a negative, meaning if I have the square root of happy face, what we know is we basically have to guarantee that this is not negative. Mathematically, how we say that is, I want this to be greater than or equal to 0. Does that make sense? If you've got the square root of stuff, we know that stuff has to be greater than or equal to 0, because if it's not, right, you can't have negative. You can't take the square root of a negative. Is that part okay? Well, look what happens if we apply that. That's inside our square root, isn't it? And if I want to know the domain, I know basically that this is my happy face has to be greater than or equal to 0. So if I take this happy face, which is going to be x plus 3, and I set it greater than or equal to 0, what happens when you solve that?
Negative.
Do you see when you solve that, you get x is greater than or equal to -3, which is our answer? Yes?
Could you also just look at it and say it's -3 without having to like explain that?
Well, that's what he was saying.
It was.
Yeah. And I said you can do that for simple examples.
Oh, okay.
So I guess the question is, what's not a simple example, right?
Yeah.
Okay. Okay. What's not a simple example? All right. Find the domain of y equals the square root of 3x plus 2. That I think is harder to do just by looking, right? But if you just set it up, right? What are we going to do? How do we figure out our domain? Greater than or equal to 0, right? Because we know what's inside has to be greater than or equal to 0. So if I set x 3x plus 2, I set that greater than or equal to 0. Did you get x is greater than or equal to negative 2/3? And some of you might say, well, I could visualize that. Yeah, no, you actually just solved that in your head, right? Whatever argument you give me, you solved it. Whether or not you wrote this step down, right, is immaterial. Right? You didn't just look at this and say the answer is negative 2, right? Remember, you actually had to solve that. So that, so can we find out what the domain is without graphing? Yes, that's good. Can you find out the range without graphing? I'm going to say sort of. Okay? Technically you can, but sometimes it gets complicated. Right? But are we okay with the domain part? Right. All right. Oh. Give you space. Don't write this down. What did the negative do with parabolas? Flipped it. Okay? We okay, the negative on the outside flipped it. So we take our parabola and flip it down. What do you think that's going to do? Flip it. Does that make sense? So instead of having, remember I told you like this is like your little square root thing is half of a parabola, a sideways parabola. When you have a negative, this is now the bottom half. So if I were going to graph this, actually I want to graph this same thing. If I were going to graph this, this says, okay, I'm going to go back 3, up 1. Everybody okay that that's where we? But instead of having it curve up, what's going to happen? It's going to curve down. Right? Because the negative flipped it.
So then why wouldn't it be negative 3, -1?
What? No. You don't distribute this.
Oh, okay.
Did you distribute, when you were graphing parabolas, did you distribute that minus sign when you graphed? I hope not. Right? When you graphed, that negative told you to flip it down, right? Well, that negative on the outside always tells you to flip it down, no matter what the it is. Again, you don't have to believe me. We can plot points. Right? If I plot points, okay, I plug a negative 3 in, this is 0, that gives me a 1. Great, I have this same dot. When I plug a negative 2 in, okay, that's 1, negative 1, that gives me a 0. I get a dot here. When I plug a 1 in, okay, that's 4, negative 2, but that gives me a negative 1. When I plug a 6 in, negative 3 plus 2 gives me a negative 2. And now when I plot all of these, okay, so I have a dot here, I have 1, negative 1, I have 6, negative 2. Do you see that when I connect my dots, I get the bottom half of that sideways parabola?
Yes.
Okay? Well, while I have this up here, let's talk about our domain. Did flipping it change our domain? Right? We're still going basically from negative 3 over, right? We take whatever's in, we take our, so in this case it's from negative 3 to infinity. Our range, that changed a little bit. How far down did it go? All the way. How far up? To 1. So our range is going to go from negative infinity to 1. See how that changed a little bit? But how you write your answer in ALEKS, you know, this one's going to be x is greater than or equal to negative 3. How do you write this one? It's going to be y.
Less than or equal to.
Less than or equal to 1. Do you see how it's going down? And so it's y less than. Could you figure out the range just from looking at it? Yeah. right? No, it's still dealing with this outside number. It's a little harder, I think. In general, it's always easy. You can always find the domain without having to graph stuff. A lot of times when you have to find the range, you need to have some idea of the picture. Are we okay with this? All right. Well, oh shoot, how did I erase that? Again, I'm just, don't write it down. This is just me referring back to parabolas because we've talked about this. And the significance now is, what does the 2 do here? Do you remember, everybody remember what it did to the parabola? Stretched it, right? So anytime you add or subtract numbers, what you're doing to the graph is you're just moving it around. If it's outside, it's moving stuff up and down. If it's inside, it's moving stuff left and right. Right? That's just what when you add or subtract, that's what it does. When you multiply, it stretches, right? It starts changing the shape a little bit. And in general, if it's outside, it changes stuff up and down. If it's inside, it does stuff left and right. Right? That's the rule. Outside is always up and down, inside's always left and right. So are we okay that 2, right? It's going to stretch. And the way I want you to think of when you're multiplying is, what I want you to do is imagine that that graph is on a sheet of rubber. And if that's a 2, you take that sheet of rubber and you stretch it twice as tall. And if you stretch it twice as tall, how does that change the shape? Right? All right, so, we already have those up here. So I want to go back to my, I should have this. So let me graph it good. Are we okay? That's my square root function. Okay. Here is, this is y is equal to the square root of x. You know, it hits this dot, this dot, this dot, and that dot. Right? Everybody okay with that? All right. What about y equals 2 square root of x? So let's think about what this is going to look like. So if we think about what this looks like, here's your graph, and I want you to imagine that this is on a sheet of paper, right? And what we're going to do to that sheet of paper, right, is we're going to stretch it twice as tall, because that's a 2, right? So if I stretch it twice as tall, what's my graph going to do? Pulled up, isn't it? Can that make sense? Does it make sense that if I put a 2 here, it's going to pull this up? Now you don't have to believe me, right? We can plot some points and try to figure this out. Oh, I need to use red. So I'll pick my XY chart. I guess I'll pick 0, 1, 4, and 9, right? Plug 0 in. 2 times 0 is still 0. Okay. Plug 1 in. That's 1. 2 times 1 is 2. Plug a 4 in. That gives me a 4. And I plug a 9 in. That gives me a 6. Everybody okay with my dots? And when I plot those dots, okay, at 0, I'm at 0. At 1, I'm at 2. At 4, I'm at 4. And at 9, I'm at 6. Does this look like it got stretched? Right? So why did it get stretched? Well, literally what we did mathematically is we multiplied every y value by 2. See how this y value was 1? When you multiply by 2, we get a 2. This y value was 2. When we multiply by 2, we got 4. When this y value was 3, when we multiply by 2, we got 6. Okay. What do you think y equals 1/2 the square root of x looks like? Right. Take that same sheet of rubber, but squish it, right? And so what happens now is we still get, this still is here, right? But now this one goes here, this one goes here. We're going to take all of those y values and cut them in half, and so we end up with this part. Get a really skinny thing. Oh, still a little curious about this is, what's your domain? Did it change the domain at all? So our domain is going to be x is greater than or equal to 0. What's our range? Do you see none of this changed your domain and range? So our range is going to be y is greater than or equal to 0. So when you multiply, like when you put these numbers here, it doesn't change your domain or range. It changes the shape, but it doesn't change your domain or range. Does that make sense? So now, okay, are we kind of okay with the square root function? What I want to make sure is that you recognize it behaves similarly to the parabola, doesn't it? We have our shape and we're doing the same things, but you know, it's just this half a parabola. All right, well, let's talk about the last one. Okay, I need one other radical thing. Need to talk about the cubed root of x. Let's see. Just delete that good. I have no idea what that looks like. Guess what I'm going to do? Make an XY chart, right? That's what we do every time we don't know what it looks like. Of course, now the challenge is, what do you pick, right? Well, I'm pretty sure I can pick 0, right? What happens if you plug a 0? What's the cube root of 0? 0. Okay, we do that. Can I pick a 1?
Yes.
What's the cube root of 1? 1. Can I pick negative 1?
Yes.
Turns into a
Yes.
positive.
No. What's the cube root of negative 1? Negative 1. Right? Because negative 1 times negative 1 times negative 1 gives you negative 1. And so that gives you negative 1, right? Okay, so we got dot here, dot here, dot here. All right, I'm fine with that. All right, what else can I pick?
Negative anything.
Like, what do you know a nice cube root of? Do we know the cube root of 8? Yeah. So I can pick 8, which gives me a 2, and a negative 8, which gives me a negative 2. And so now when I look at this, at 8, way the heck over here, I get a 2. Way the heck over here, I get a negative 2. And if I were to connect these dots, you know what? I give up. Oh, the right half I got pretty close. I need some help on the left. So we get this little S shape, right? And so here's probably the easiest question I'm going to ask all day. What's your domain?
All real numbers.
Everything, isn't it? And actually, in ALEKS, they'll want you to say all real numbers. I think they even have a checkbox. You can say all reals. Wait. So, negative infinity to positive infinity. Okay, here's an easier question. What's your range? Same thing. You see it goes all the way down, all the way up? All right. Does that make sense? And my last example for today is, all right, so yeah, because the cube root function just is everywhere. There's no real restriction, so it just goes everywhere. What do you think y equals 2, x plus 3. Oh, no. What have we done to our graph? Everybody recognize we have the cube root function, right? What's the plus 3 tell me to do?
Left.
Go left 3. What's the minus 4 tell me to do?
Minus
Down 4. What's that 2 tell me to do? Stretch it, right? So if I had to guess at what this graph looks like, I'm going to go back 3, down 4, right? I take that center point and do this, right? And now instead of this doing like a little wave, everything gets stretched by a factor of 2. And since everything's getting stretched by a factor of 2, I think it's going to look like this, but see how it's bigger? But again, don't take my word for it. I got better. Oh, you can't see this, right? Because it's really small up here. But there is no cubed root. This program I'm using doesn't have like a cube root symbol. So instead of writing a cube root symbol, what I have is all of this written to the 1/3. Right? Like I can't just graph. There is no cube root x, right? What I have to do is write x to the 1/3. But we did learn something about rational exponents. What does that equal? Everybody see x to the 1/3? So if you, like, calculators may not have like a cube root button or a 4th root button. But all calculators have, you can raise it to a fraction. So if you want the 4th root, it's to the 1/4. Does that part make sense? All right, so your homework. You have some graphical. Let me hit pause. Actually, go ahead and hit stop.